Hello, I just wanted to post a quick video, 10 minutes, showing you about how to use the graphing calculator to do a scatter plot, work on correlation, and to do things like construct the least squares regression line, LSRL, and maybe talk about some other terms in scatter plot land such as variability and giving the four S's for correlation. Well, over my shoulder right here, we've got a list 1 and list 2 full of information. List 1 is the horsepower of a car, and the second list is the miles per gallon. How are the two associated with each other? The scatter plot will actually show us. So by now you probably do know how to get that onto your calculator by pressing the Stat button and hitting Enter. And you can type in those lists, list 1 and list 2. So do that. You can pause the video, and then when you're ready, unpause it. Alright, so now that you have both of these into your calculator, you can come up with a scatter plot by pressing second and y equals. It brings you to the stat plot menu, hitting on and hitting enter brings you to the menu where you can select on and also the scatter plot, which is the first choice. Highlight it just like I did. Your X list is the horsepower, your Y list is the miles per gallon. If you hit zoom 9, zoom in the number 9 brings you to the scatter plot. Well, you didn't need to do this. You could do this on your own. You don't need a calculator to have it displayed displayed to you. You can actually just do it by hand. But it's a nice, neat way of actually having it right on a little screen. Next thing we want to do is maybe come up with the line of best fit and also get something called the correlation. To do that, make sure that your diagnostics are turned on in your calculator. To do that, you want to press second and 0. Second and 0 will bring you to the catalog menu, and then scroll down till you get to the D's. The catalog shows everything that the calculator can do in alphabetical order. So eventually you find your way down to the D's, and you want to turn your diagnostics on. That lets your calculator know that you want to be able to find things such as the correlation. Okay, with that done, we can get the line of best fit and the correlation by pressing Stat, the Stat button to calculate, and then you may go to choice 4, which is the linear regression command. Using list 1 and list 2, it'll give you a readout full of important information. And you can copy that down, which I will do right now. So this is telling me that my line of best fit has a slope that's negative 0.09 and the y-intercept of 38.5. Okay, once again, I'm just getting that from the calculator. It tells me what the slope is and tells me what the y-intercept is. They're also giving me two other numbers. R squared, which is 77.77, and they're also telling me that R is negative 0.878. All right, let's talk about what each of these things mean. First of all, the line of best fit. The line of best fit is a line that represents this data, and it's the best line that we could possibly come up with that summarizes what we see in the data. To put that into the calculator and actually see it, one way is just to type it into the calculator, pressing y equals, and then typing in the equation by hand. Negative 0.09x plus 38.5. So that's one way to actually get this on your screen. Hit graph, and it will throw the line through the cloud of points. There's no guarantees that it'll actually hit any particular point that's on the scatter plot already, but it summarizes what's there pretty well. As you can see, it's kind of balanced on either side, and does look like it actually pierces through or nearly hits some of the points that are actually there. As far as what these two numbers represent here, the slope and the y-intercept. The slope, well, for every increase in x, and x is our horsepower, so for every extra 1 horsepower that we add, for every extra horse that we add for power, this is predicting that the miles per gallon, the y value, will go down negative 0.09 miles per gallon. So it's showing that as the horsepower increases, the line of best fit is telling us that the miles per gallon will decrease. For the y-intercept, the y-intercept is where the line of best fit crosses the y-axis, or when x is equal to 0. So if we had a car that didn't have any horsepower, according to the line of best fit, it would get 38.5 miles per gallon. It's kind of a weird answer, because how could you have if you didn't have any horsepower at all, your car's not moving at all, you wouldn't get any miles per gallon at all because your car wouldn't be moving. So that's kind of the danger of extrapolating or going beyond reasonable numbers that are off of our list, is that you'll get answers that sometimes don't make any sense. They'd be very bogus answers. So, but that's what the y-intercept would mean in theory. So how well did the line of best fit do? R squared is a measure of that. R squared is called the variability. It is also called the coefficient of determination. It's basically the grade that you would give the line in terms of how well did it do. How well does this line explain what's happening in terms of the connection between horsepower and the miles per gallon? And it gets a passing grade, 77%. 77% of the variability in miles per gallon can be explained by the horsepower. In other words, horsepower is responsible for, or can explain, about 77% of the car's miles per gallon. 23% of the miles per gallon are due to other influences, such as shape of the car, weight of the car, other types of phenomenon associated with the car. So it gets a pretty decent grade with the variability. Now, in terms of the last number here, R. R is the correlation. Some students get these mixed up between the two. This is the correlation coefficient, or just the correlation. The correlation measures a few things for us. I like to call them the 4 S's. And I know that if you're taking the AP stats exam, they're going to want you to give as many of these as you can based on an answer like this. So if they ask you to find the correlation, or I do in my Niagara exam that I'm going to be giving, or my tests during the school year, if they ask you for the correlation, I'm going to want more than just the number. I'm going to want some information to back up that number. What does that number actually represent? Well, the correlation represents how tight these points are to the line. And you can see that some of the points are actually very, very tight, and some of them are off of the line. But it's actually showing a very good, pretty tight relationship between the line and where the points are. In terms of actually writing this out with the 4 S's, once you have the number written down, the important things to point out is the sign. This has a negative correlation because it's sloped downward in the line of best fit, because it's negative. The sign is one of the 4 S's. The next one is the strength. Because this is between -0.5 and -0.9, I would mark this up as being moderate or medium strength. We'll talk more about the strength in a minute. In terms of how you measure what's a medium strength and what's a strong strength and what's a weak strength. As far as the shape goes, that's something that you can pull off of looking at the scatter plot. Okay, the scatter plot is showing generally a pattern that is going downward, and generally a pattern that is pretty much in line. I'd consider this relationship to be quite linear. There's not a noticeable curved pattern with like a horseshoe pattern, or where the points start up maybe really high in this corner and then swoop down and then come back up again, or it's not going in any other way across the screen. The shape is sort of your impression of what you see there, and this is linear. It looks like the points are lining up pretty well. And then the last S is the story or the situation. So we want to throw in the context of what's happening with the graph in real life. And a good way to say that is to start off with the two words in general. Okay. In general, as horsepower increases, the miles per gallon decrease. Not true of every single car or truck that's on the list, but in general, that's the flow of the points that's happening. All right, one last thing to give you is just a little thermometer when it comes to measuring correlation in terms of how strong it might be. If you think of it as a number line, the lowest the correlation could be is -1. The highest it can be is +1. +1 means that the points all show up in a straight line and that the line is an upward trend. That has a correlation of +1. Perfect correlation. If it has a correlation of -1, it means the points all line up and are going in a negative direction. If I threw a few more points on here, it would ruin the correlation a little bit, but the correlation would still be very strong because the points are very close to the line. So this might have a correlation of -0.97. So a strong correlation is anything usually or typically above +0.9 or below -0.9. If it's between +0.5 and +0.9, it could be considered a medium strength or moderate correlation. Or if it's below -0.5 to -0.9, it could be considered to be a medium or moderate correlation. Anything in between, 0 would be completely no correlation at all. Anything in between +0.5 and -0.5 is considered to be a weak correlation. So there's a quick, I guess it ended up being closer to 13 minutes, explanation about what scatter plots and lines of best fits are mostly about. And this would be a good way to review before the exam and just strengthen up on your skills for using the calculator. And just keep on working really hard at it. Of course, if you've got more questions, you can always email me, and I'd be willing to take suggestions for another video, too, if you have something else you want to learn about. So good luck, and keep on fighting the good fight.